I'm really happy to give you an introduction to neuroeconomics. This is an exciting new interdisciplinary field that combines neuroscience, economics, psychology together in order to build a new unified theory of human decision-making. So during this course, I will give you an introduction. So I will not give you all fields or directions in the neuroeconomics. So today, I will try to present you main assumptions of neuroeconomics. During the next lecture, I will give you major brain imaging techniques of neuroeconomics. So that would be the module 1 of this course. During the module 2, I will present you the major models of neuroeconomics, and we will understand how brain makes decisions. During the module 3, we will focus on emotional mechanisms of decision making. So we will discuss how affects emotions, modulate and program our decisions. And finally, during the module 4, we will discuss how decisions are made in various social contexts. We will also focus on evolutionary basis of decision making. We will discuss some similarities of our decision making and animals' decision making. Can we find similar financial decisions in humans and monkeys? So that will be the topic of our final module. So now I will give you a few hints what you can expect in this course and what you shouldn't expect in this course. So first of all, this is a relatively short introduction to neuroeconomics. If you would like to read about some specific directions in neuroeconomics, you will have to read additional literature. Of course, I will focus on limitations of neuroeconomics. Neuroeconomics uses a lot of brain imaging techniques. All of them are limited. So at the moment, perhaps we cannot address all questions related to decision making using neuroeconomics approach. And you will face trivial and non-trivial facts. As neuroscientists, you can a bit irritated by my version of neuroscience, a simplified version of neuroscience. As economist, you can be irritated by the simple version of economics in this course. But I do it on purpose, because we have a very multidisciplinary audience. So in order to build a joint language, to merge our group together, I will try to use some simplified terms and concepts to create a common theory of decision making. So we will discuss various paradigms, and we also focus on quite difficult papers. So be prepared that majority of neuroeconomics papers are written by neuroscientists, and they use quite specific language. So it can be quite complicated, it can have a lot of technical details, so be prepared to read quite complex papers. Please do not expect a unified theory of neuroeconomics. This is a very young field, so it doesn't have right now a unified theory, but have a lot of different concepts that in the future, perhaps, will be organized in a unified theory of human behavior. So we will not discuss all aspects of neuroeconomics during this course. And unfortunately, because this field is very young, there is no one single easy-to-read handbook. So be prepared to read quite complex papers. So overall, neuroeconomics is based on a simple but astonishing hypothesis. This hypothesis is very nicely formulated by Francis Crick, the Nobel Prize winner, who just suggested that our mental activity, our decisions, is nothing more but the activity of our brain. So our mental activity is simply a biochemical process in our neurons, in our neuronal population. This is a very simple idea, but it can be quite easy to accept it for neuroscientists. But at the same time, it can trigger a conflict for social scientists. So from this perspective, our decisions, our mental activity, is nothing more but the activity of our brains. If you are against this idea, if you are against this astonishing hypothesis, you anyway have to adopt this idea for this course. So this is basically the foundation of neuroeconomics. So strictly speaking, neuroeconomics is a field combining psychology, neuroscience, biology, and economics together to build a unified theory of human behavior. Of course, neuroeconomics focuses on decision making, and we will dedicate this course to the neurobiological aspects of decision making. Neuroeconomics is very much influenced and dominated by neuroscience. So already now, in the key handbooks on cognitive neuroscience, you can find a chapter on neuroeconomics. But of course, there are also books specifically published by neuroeconomists. I strongly recommend you to read books created by Paul Glimcher or by key neuroeconomists. I will give you some hints which book I would recommend you to read during the course. Of course, we can use another label for neuroeconomics, neuroscience of decision making. Actually, this second label is becoming more and more popular. So we can use either the term neuroeconomics or the neuroscience of decision making. Both terms try to emphasize that neuroeconomics focuses on the neurobiological aspects of decision making. So neuroscience is a field of biology that traditionally focus on nervous system, and this is a branch of biology. So traditionally, neuroscience investigates neuronal networks and activity of the neuronal networks underlying our behavior. So for example, here we can trace all neurons that are programming our voluntary movement. This network starts in our sensory neurons, and next the information is translated to cerebellum, to thalamus, to motor cortex, and motor cortex sends information back to muscles. So in simple situations, when we program very simple voluntary movements, a limited number of neurons is involved into the programming of our motion. If we have more complex goal-directed movements, of course, more neuronal populations are involved, and it can be quite complex neuronal network. But neuroscience suggests if we would understand how this network is working, we can understand voluntary movement, and we also can understand how decisions are programmed. For neuroscience, it's enough to understand the neurobiological machinery behind the decision making to fully understand decisions. So from the neuroscience perspective, our decisions are programmed by neuronal networks. So somewhere in these complex networks, our decisions are programmed and sent to the motor system. Of course, at the end, neurons are communicating with each other by synapses. So somewhere in this synapses where chemicals are produced for communication between neurons, our decisions are programmed. So traditionally, our behavior has been studied by various fields of science. So, of course, we understand that our decisions, our behavior, is affected by our genes, by our neuronal activity, by the activity of the whole brain, by our cognitive system, by the society, by social context, and by the environment. So traditionally, all these aspects of decision-making were studied by different fields, by neuroscience, by cognitive psychology, by social sciences, by economics. What is the ambition of neuroeconomics? To merge all these fields together and create a unified theory of decision-making. So this is a very ambitious plan, but this is a very exciting and provocative idea. And I hope that you will also get this excitement about this new provocative field from this course. So what is the reason to combine economics, psychology, and neuroscience together? I think there is a very fundamental reason to do it. So all of the sciences have own biases. They are very much limited and narrowed by own field. So they have certain assumptions that are quite often violated by different fields of science. So I will just give you 3 examples how very important major assumptions of different sciences are violated, questioned by different fields of science. So for example, economics. Normative theory of economics suggests that we are rational, that we make our decisions rationally. So it suggests that our decisions are consistent and logical. Economists in this audience well know a famous example, so-called Asian disease example, illustrating a lack of rationality in our decision-making. But biologists and people from other students from other disciplines perhaps do not know. So I will once again mention this famous example, so-called Asian disease example. Imagine that there is an outbreak of a strange Asian disorder in the United States. This disorder is expected to kill 600 people. Imagine that you are in the special medical committee, and this committee has to select one of the programs to treat this disorder. According to the program A, if program A is adopted, 200 people will be saved. If program B is adopted, there is a 1/3 probability that 600 people will be saved and 2/3 probability that no people will be saved. So which program would you select? Think for a moment. A lot of people, and many studies show this, prefer the program A, because this program guarantees that 200 people will be saved. But let's now make a decision and select between two other options. Imagine that you are offered by two other programs. If you will adopt program A, 400 people will die. If you will adopt the program B, there is a 1/3 probability that nobody will die, and 2/3 probability that 600 people will die. So which program would you select now? Think for a moment, and many studies show that people prefer program B here. But come on, let's stop for a moment and compare these two programs. So these two versions of this experiment. You can see here that these are identical options. Just make a look to the program A in the first example. If program A is adopted, 200 people will be saved. But this is an identical program to the program A below that states that if it is adopted, 400 people will die. These are two identical programs, but they're framed in a different way. So in the first case, it is framed as in a gain domain, so 200 people will be saved. But in the second case, it is framed in the loss domain. It suggests that 400 people will die, but these are identical programs. So surprisingly, simply the framing of the options can change our decisions. So our rationality is quite limited because we cannot say that we are logical and we are consistent. Our decisions are very much dependent on the framing of the options. So psychology many times questions the assumption of the normative economics that we are rational, that we make rational decisions. But psychology itself suffers from some own biases. And I like so-called circular reasoning problem criticism. Psychology investigates our behavior, and based on our behavior suggests some cognitive process, cognitive systems that can modulate our decisions. Memory, attention can modulate our decisions. But psychology studies our behavior, and based on behavior suggests some cognitive systems, cognitive process. But in fact, they explain behavior by behavior. Does it bring us some new insights to the mechanisms of our behavior? Should we go a step lower to understand our mental activity, lower from our behavior, for example, to the neuronal level, in the same way as nuclear physics? In order to explain our macro-level physics, try to study the structure of our atoms, atomic structure. And this perspective would bring us completely new insights to the macro level. So in the same way, to avoid the circular reasoning problem, we have to go one level lower. And for example, explain our behavior, our decisions, by neuronal activity. That will bring us new insights to the actual mechanisms of our behavior and our decision making. At the same time, neuroscience suffers a lot from the tradition to investigate the single brain. So neuroscience is very much egocentric. Neuroscientists really believe that if we will investigate the single brain of a single individual, we can understand the brain mechanisms of decisions, of our behavior. But in reality, we never make our decisions alone. In reality, we make our decisions in social contexts, in interactions with others. I really like this experiment conducted by a postdoc in Cambridge. It's a very simple experiment, but it is very illustrative. Imagine that this scientist just feeded ducks in Cambridge in a lake. So he feeded ducks with a constant rate, 2 grams per 5 seconds. His friend on the other side of the lake feeded also ducks, but with a slower rate, only 2 grams per 10 seconds. So what should you do as a smart duck? Perhaps you will go to the place where there is more food available. But if all ducks will go there, you will have a shortage of food. It will be smart to go to the side B, where there is no ducks. So your decision depends very much on the decisions of others. And if we will make a look to the distribution of ducks in this experiment, very quickly the number of ducks is distributed in a very rational way according to the Nash equilibrium suggested by decision theory, by game theory. So when you make your decision is very much dependent on decisions of others. And it's very nicely illustrated by economics and also by psychology. So in order to understand our decisions, we have to understand how decisions are made in social context. How do we take into account decisions of others? So altogether, neuroeconomics is trying to combine various fields to build a unified theory of decision making. So genetics, economics, psychology, neuroscience are merging together to build a unified theory of decision making.